All right, picking back up. I know we had a long lesson today, but picking back up with those notes, really, here's the first big thing with polar that we need for calculus. Right, all the stuff in that last video that we covered in class today, or later if you're watching this video, we may not have done it today, but all that stuff for the pre-cal, right? That's to kind of get us used to what the polar graphs look like, how I can switch back and forth between polar and rectangular, and vice versa. That's great. But the two big calculus ideas, right, are a derivative, finding the slope of any graph at any point, and an integral, which specifically a definite integral, finding the area bounded by any graph over any specific interval. And those are the two things we want to be able to do with the polar stuff for now. We want to be able to find the slope of a polar curve at any point, and then we also are going to want to find the area bounded by those weirdly shaped polar graphs, right? The limicons, cardioids, the rose curves, all that good stuff. The slope of the graph at any point, that's what we're going to do today. We have that. We have just this first kind of example where we're going to be proving the formula, and then the second, which is actually just working that and doing one. And this is going to be probably a fairly short-ish video because these questions are long. Okay, there's only one example in the notes, but we're going to kind of work through the formula, and then we're going to do one example with it, and that's the goal of this video, is to get the slope of a polar curve at any point. And then I will make a different video, probably two different videos, over doing the area bounded by those polar curves. But let's just do the slope one today. Now, important things for us to remember. X is r cosine theta, and y is r sine theta. We need those. This formula is hideous. You're not going to want to try to just memorize the formula. Instead, you're just going to want to remember x is r cosine theta, y is r sine theta, and we're just going to want to remember how to prove this formula again. This is one of the few things in math that it's easier to just prove it later than to try to remember the formula, because it's an uggo, right? But what we want is dy dx. Remember, that is the only derivative that gives us the slope of the graph, whatever it is, the slope of the graph at a point, right? Only dy dx. The problem is that we have this thing that's not rectangular, so it's not going to be in terms of y and x. It's polar, so it's going to be r equals, right? Our polar equations are usually r equals, and it's usually defined by theta. So how do we somehow get dy dx if we have r's and thetas? Well, x is r cosine theta, y is r sine theta. Here we go, right? We're going to have to use product rule because r is going to be a function, right? Kind of like down here, r is a function, and then cosine theta is a different function. And what we're going to have to do is product rule. We need dy d theta. We're going to take the derivative of this on top. It's going to involve product rule because we've got r times sine of theta, and then we're going to do the derivative of dx, or we're going to do the derivative of x with respect to theta also. But if you can remember, that x is r cosine theta, and y is r sine theta, and if you can remember how to do product rule, which we should, then this derivative is not terrible to prove, but it's a really ugly formula. Here we go, right? Let's do the top first. Remember, let me do a different color. Remember, y is r sine theta. Y is going to be its own function. So think about this, right? We have these two chunks, r times sine of theta. I'm going to need the derivative of the first, the derivative of y, the derivative of r, so dr d theta, the derivative of the first times the second, plus the derivative of the second, that's going to end up being cosine of theta times the first, which is r. So we have dr d theta times sine of theta. The derivative of the first chunk is r, times the second, which is sine theta, and then the derivative of the second times the first. Right? We have r times sine of theta, so I need the derivative of r times the sine of theta, plus r times cosine theta. It's easier to just reprove it than to try to remember it. And then on the bottom, we need the derivative of r times cosine theta. So I need the derivative of the first, dr d theta, the derivative of the first times the second, plus the derivative of the second. Now the derivative of the second is negative sine, the derivative of the second times the first. Whew, and there we go. There's your formula. All right, that's the formula for finding the slope of the polar curve at any point. It's not very nice. You could rewrite it if you wanted to, just a little bit. You could rewrite it as r cosine theta plus sine theta times dr d theta. And then you could rewrite it as on the bottom. I don't know why you would really write the negative one first, but I guess you could. Negative r sine theta plus, and then we have the cosine theta dr d theta. I mean, sometimes you'll see people rewrite it. Honestly, it doesn't really do anything for us, but either one of those is perfectly fine. Right? Those formulas are both equally correct. I probably would just remember this. Remember, we had the top, which was y. Y was r sine theta. Have to do product rule. R times the sine of theta. The derivative of the first times the second plus the derivative of the second times the first. And then we have x equals r cosine theta. You have to do the product rule in the denominator as well. Right? It's an ugly, ugly formula. You won't see a whole lot of these on the AP exam. Usually there's like one or two, probably just one, because these are just, they're long questions. All right, here we go. First example, only example we're going to do, and then we'll be done with finding these slopes of the polar curves. It says find dy dx and the slope of the graph of the polar curve at this given value. Here's my thing. Remember, x is r cosine theta and y is r times sine of theta. Okay, so if I want the slope of the graph, that's dy dx, I'm going to need to do dy d theta over dx d theta. And so here we go, right? Let's do the derivative on the top again. I'm going to need the derivative of r. Let's go for it. There's r. The derivative of that would be 2 cosine theta. There's my dr d theta, right? The derivative of r times, right? I did the derivative of r times, now I need sine of theta. So remember, I'm taking the derivative of r times, if you want to, you can just plug it in, right? If you want to, you can plug it in. Might as well. Like y equals 3 plus, this may help you. So that way we're not looking all over the place. Y is r sine theta. And then here we're just going to be doing this product rule. The derivative of the first times the second plus the derivative of that second, again, is cosine theta times the first. So I'm just going to copy 3. Oh, I need probably more space. Really doesn't matter which order you write it. 3 plus 2 sine theta times the second, times the derivative of the second. So again, your product rule, since y is r sine theta, we have to do product rule. The derivative of the first times the second, which you just copy, plus there's the derivative of the second times the first. All that stuff, right, is in your numerator. It's just following that same formula. We take the derivative for r, plugged it in, then sine theta, there it is. Then we just copied the r, there it is, and then the cosine, bam, right? Here we go, let's do the bottom. Remember, x is r. I think it's probably just easier to plug this in. R cosine theta. And then we need to do that product rule. Here we go. The derivative of the first, again, is 2 cosine theta. The derivative of the first times the second, plus the derivative of the second. But the derivative of cosine is going to be negative sine, and then times the first. So I just copy 3 plus 2 sine theta. So that formula is kind of ugly, but if you can remember that x is r cosine theta, y is r sine theta, you're going to be told what r is. So then you can plug that in, and as long as you can remember those two basic things from pre-cal, and then you can do product rule, this formula, while it's long, I mean, it's just easier to reprove it later on the spot than to try to memorize it, because that's a really hideous formula. But yeah, there it is. That's the equation that we would need to use in order to find these polar slopes. Now, you could try to simplify it, but honestly, that's probably fine, right? There's our dy dx. So we found dy dx. You could try to distribute and combine some stuff, like that's cosine squared on that bottom left, sine squared on that bottom right. Okay, but we're just going to plug it in, right? We're just going to plug all this stuff in, and we're going to evaluate it at theta equals pi over 6. Let's go think about pi over 6. Pi over 6 would be this point where you go over a lot and then up a little. So your cosine value is your root 3 over 2, and then your sine value is 1/2. So let's just go plug those in. All right, so this derivative, having been plugged in with the pi over 6, I need 2 cosine of pi over 6, which is root 3 over 2. Then I need the sine of pi over 6, which is 1/2, plus I need 3 plus 2, and then the sine was 1/2. And then I need the cosine value, which is the root 3 over 2. And then I need 2 cosine cosine. So I've got 2, the cosine, and then the cosine. And then there we go, minus. Then I'm going to copy that same chunk, 3 plus 2, and then the sine. And then I need the sine value. Woo, all right, so that was kind of ugly. But we went and we got the cosine of pi over 6, and we got the sine of pi over 6. We just took those, plugged them all in. Let's look at how this is going to potentially cancel and how it's going to reduce. That 2 is going to cancel. That 2 is going to cancel. Let's see. Those are going to cancel. Those are going to cancel. So all of this stuff, right, it's going to be 3 plus 1. All that stuff's 4. So let's just work on simplifying it. Here, that top left, we're going to have the root 3 over 2 plus, and then I have 4, and then the root 3 over 2. And then let's see, those 2's canceled, so I'm going to have 3 over 2. And then let's see, that's going to be minus 4, and then the 1/2. So we're just simplifying it kind of a little bit at a time. Let's go ahead, and I'm going to actually get rid of all this, so that way I can kind of take this work and continue up here. Let's go to the next step. Let's see, 4 and 2, that's going to reduce. So I have root 3 over 2 plus 2 roots of 3, and then I've got 3 over 2, 2, and right, that's going to reduce, so minus 2. All right, so we still probably are going to want to combine this and make it look a little bit nicer. Let's keep going. Let's just multiply everything, right? Multiply everything by 2 over 2. Multiply by 1. So multiply everything by 2. So I'm going to have root of 3 plus 4 root 3 over, let's see, we multiply by 2, that denominator gets killed. Then it's going to be 3 minus 2 times 2 is 4. Whew, we're getting there. We're getting there. Let's see. Root of 3 plus 4 roots of 3. That's 5 roots of 3. 3 minus 4 is -1. Okay, so here we go. We're finally ready. -5 root of 3. Woo! That's not fun. All right, it's not fun. It's not super nice. Not super easy. Again, that formula is hideous. But that's the formula you have to use in order to get the slope of the graph, which is only dy dx. In order to get the slope of the graph at the point, you have to know that. Y is r sine theta. Plug the r value in, then do your product rule. That's the numerator. X is r cosine theta. Plug the r value in, plug in what that function is, then do your product rule. That's the denominator. That's how you get the derivative. And then if you have to evaluate it, so be it, right? You go plug it in, you have all those numbers, plug it in, and gradually reduce it, and then all the way you'll get to this answer, right? That's what the slope of the graph would have been. If you wanted to do like the equation of a tangent line, you'd have to plug in the x to the x equals r, and then I guess you'd have to plug into the r value. You could plug into x equals r cosine theta, and then when you plug in the pi over 6, you could find the x coordinate at that point. You could find the y coordinate of your point, and then that would be the m value if you were doing the equation of a tangent line. That -5 root of 3 would be the tangent slope. Right. So this derivative of or the slope of these polar graphs, it's not nice. And again, that formula is hideous, but it's probably just easier for you to just remember the process. Y is r sine theta, x is r cosine theta. You got to do the 2 product rules. It's probably just easier to reprove it on the spot than it is to try to memorize it. Ultimately, these questions aren't super common because they're super long. They can't put a bunch of these on the AP exam because then it would be they're too long. So ultimately, like, they're not critically important, but we can find the slope of these polar graphs also. It's just kind of that really long roundabout process. There we go. That's it.